This is Hannah and I'm going to talk to you today about our water filtration kit. This is a really fun interdisciplinary STEM kit that utilizes both math and science together to help tackle real-world problems. So, let's get started with the assembly. First thing we need to do is build a meter stick vertical stand like I have here. To assemble this piece, collect 6 number 2 unsharpened pencils, a meter stick, and the following pieces. Once you have everything assembled, start by inserting the unsharpened end of the pencil into the bottom 3 openings like this. You can do the same thing with this top piece. Next, insert your meter stick and do so through the top and then through the bottom, being sure to line up the pencils so that they all line up. So we take these last little pencil angle pieces and we take the short side and snap it onto the bottom pencil, and the long side snaps onto the angled pencil. And there you go. You have a meter stick vertical stand set up and you're ready to assemble the rest of your kit. Once you have that, select whether or not you're going to be using 2-liter bottles or either 12 or 16 ounce bottles. Next, use scissors to cut the bottom off of one of the water bottles. On that bottle, screw the bottle funnel onto the end. Then, take your 2 bottle supports and secure them to each of your 2 bottles. You may need to add a rubber band around the 2 loops on the edge of the bottle support to hold it in place. Next, lift the meter stick up out of the bottom piece, but not out of the top piece of your meter stick vertical stand, and then slide it back down, being sure to include the bottle support that is secured to the full water bottle. Next, you get to choose how you're going to filter your water. So, use your water bottle here that's cut off at the top and fill it up with whatever filtration devices you would like. One of the best things to do with this is then put a cost associated with each item so that students then have to balance the cost-benefit analyses of these different materials and can determine what the most optimal combination of objects is given the price. This is a perfect place to integrate percentages because then you can adjust the cost of certain items by raising it 5%, and then the students have to reevaluate their analyses, is this still the best option, and so forth. Then, once the students have decided what they want to do, you can have them start filling in their water bottle, the top one, with these objects. Now, one thing to note is if you're going to be using activated charcoal, you'll want to rinse it first. Otherwise, when you run it through the filtration system, it might give the water a little bit of a black coloring. Once you're satisfied with the accumulation of items you've chosen, simply slide this over the top of the meter stick to where the funnel sits on top of the other water bottle. So now that you've got it ready, this is a great chance to start talking about some of the different reasons you might need to filter water. This covers a lot of the human environment interaction standards. You can also do scatter plots and compare the turbidity, pH, and conductivity before and after. So certainly be sure to save a sample of your original water source so that you can use it for pre-tests and post-tests as you analyze these different ways of filtering the water. And you can even then integrate it in with unit rate and flow rate, trying to improve the rate of the water. For instance, how does a coffee filter affect the flow rate? Figure out things like that and get the students really experimenting and doing these open-ended explorations where they're supposed to find the best solution. Now, one thing I want to mention up front is that after this experiment, this water will not be safe to drink. Do not drink the water. It would still require additional steps and additional processes to become potable. If you were doing this for your classroom, you'd want to do probably a 5-gallon bucket and just make it really nice and dirty like we've got here. That way the students can really see a good before-after picture of what even a simple filtration system like this can do for the water quality. Immediately you can see, looking at the water that is coming out of the filtration system compared with the water that went in, the drastic improvement in water quality just by pure color alone. There's a lot less dirt, there aren't any more sticks or leaves in it. Whether you're using this in the math classroom or the science classroom, I hope you enjoy the chance to become your own engineers and help your students become able to tackle real-world problems such as clean water, and that you inspire them to work through the math, to work through the science, to figure out the best solution to a complex problem. Thanks for listening, and don't drink the water.